Hi y'all, welcome back. So let's continue our epic saga. Firstly, I want to recap what we have found in the previous video. So the previous video, we finally evaluate our two amazing integral, right? And what result did we obtain? We obtained two things. The first thing, our I1 is 2/3 Vx infinity times delta. And the second thing we obtain is our I2 is a over 15 Vx infinity square times delta. Okay. Um, okay. So the next step I would say is, so step 2, plug in above result to solve for delta. Okay, so from 8.4, what did we get? The equation, what's the equation? Vx infinity times d of I1 over dx equal to di2 over dx plus tau w over rho, right? Because I1, I2 is the two integral, and I don't want to rewrite a whole integral. That's why I named them I1, I2. And we already have I1, I2 right here. Okay? Now, let's go ahead and expand it. Vx 50 times d dx of, we have I1 already, which is 2 over 3 times Vx 50 times delta equal to d over dx of a over 15 of Vx infinity square times delta plus tau w over rho. Okay, I'm gonna go ahead and expand these. Okay, recall that Vx infinity is a constant. Vx squared is also a constant, so you can put on a constant out. 2/3 also constant, 8 over 15 also constant. You can put all that out, so you get Vx infinity times Vx infinity times 2 over 3 times d delta over dx equal to a over 15 times Vx infinity square d delta over dx plus tau w over rho, right? Let's clean it up a little bit. So 2 over 3 times Vx infinity square times d delta over dx equal a over 15 Vx infinity square times d delta over dx plus tau w over rho. Okay, I will subtract a over 15 Vx infinity squared d delta over dx both sides. And I get, 2 over 3 minus a over 15, which is 2 over 15, right? Vx 50 squared d delta over dx equal tau rho, tau w over rho. Okay, but here we have a problem. We simplify the equation. Okay, the equation is really nice. We simplify it. However, there is a problem, and that problem is we don't know what is tau omega. Right? We have to express tau omega as a function of delta. Because you remember the goal again is to find delta as a function of x, but now we don't, what is tau, right? This is a mystery element of our ingredients. So how do we find that? So there's equation in the textbook, you can find it. Alright, to obtain expression for tau w, you can use equation 8.13, page 422, and if you use an electronic copy, it should be page 441 out of 807. There's also a more in-depth equation, so if you want more in-depth derivation. You can check equation 5.60, page 277. If you use an electronic copy, it should be page 296 out of 807. Okay, so in the next part video, we will see what equation is that.